So for these, which are called identify exponential graph, and then later you'll see ID or identify log graph, you're going to take a look at this picture. You're going to think about some features that you can deduce from looking at this, and then kind of do process of elimination. It has to be one of these. Okay? So let's remind ourselves that the configuration of log or exponential graphs look like this. There are different pieces of it, okay? And what's going to be important for these are the base, of course, this, which is really your horizontal asymptote, kind of the floor or the ceiling. Sometimes you might see a horizontal shift here. And what's more important about this A is whether it's positive or negative, whether it's greater than 0 or less than 0, okay? Because that will determine whether you have a reflection. Okay, so let's just look at this as an example. What do you see here? And the other important thing is that you should have in your mind the standard form. The standard form is this. You have your vertical or your horizontal asymptote there, and it rises above the asymptote and it grows. Okay, that's your classic 2 to the x. Okay, and of course you have a positive 1 out here if it's not written. Okay, so what do you see here? Well, hey, the asymptote moved. Vertical asymptote moved. So we're going to be looking for a constant term. We're going to be looking for this as a -1. All right, well, so you can cross out the ones that don't have -1 as that constant, because right here, you're going like that's y equals, -1. Y equals -1. And it's going to be between these two. All right, well, what's the difference between those two? The difference is this has an A that's negative. This has an A that's positive. That's -1. This is +1 in terms of your A value. And what effect would that have? Well, if A was negative, your classic, this graph right here would reflect. But do you see that doing that? Do you see it? No, it's not. It is not. So this would be the wrong choice. It would certainly be this one. For the log graph, like we did before for the Expo graph, you want to have the standard visible in your mind or literally on paper. That's the standard log base 2 of x. Or actually, don't worry about the base. The base is hard to kind of like see. Let's call it just log of x. And remember, your log general function looks like a, and let's just say log base 10 of x. And you could add something to this, and that's very important actually for figuring out your vertical asymptote. Okay, so what are the effects of these? This is going to matter in terms of mostly whether it's positive or negative, okay, because that'll have a vertical reflection aspect to it. This is hard to see. Shift up and down, shift up or down. But this part is very important. And this is going to determine your vertical asymptote. Actually, the whole thing, the vertical asymptote. And remember, it's about what makes the argument 0. What makes the argument 0? What is x if the argument is 0? Okay. But graphically, you've got to notice, you've got to see, hey, the asymptote is supposed to be here, but it's not. You can tell. Instead, it moved. Where did it move to? It moved to this equation, x equals 1. Okay. So if x equals 1, we're basically saying the argument is 0 when x equals 1. When x equals 1, the argument is 0. One of the, well, maybe more than one. There might be another thing, but one of these arguments, the x equals 1, will cause it to be 0, like this one. This one, the VA would be x equals -1, right? Because it says +1 in there, so that doesn't count. How about this? If I replace this with a 1, would this argument be 0? No, it'd be -2. Okay, so that doesn't count. How about this? If I place a 1 here for my x, will this be 0? Yes. So that's a possibility, that's a possibility. And guess what? Here, the argument is just this piece, not that 1. If there's no parentheses, you just assume whatever's next to the log, that's the argument. Same with this. That's just a plain old x in the argument. Okay, now this one, same as that, same as this one. So that one is a go, and this one is not. Because if I replace x with 1 there, I ain't got no argument with 0. I got an argument of 2. Okay, so I have 3 possibilities. Let me mark them in orange here. This one, and this one. Now, what else do you notice about the shape of this graph? Compare it to your standard, right? Hey, the standard one, this is rising, okay? This is rising from the asymptote. This is not rising, this is falling. So what does that mean about the function, the equation? It means that this A is negative because it basically did a vertical flip. Up is down, down is up, right? This is going up when it moves away from the asymptote. This is going down when it moves from the asymptote. So it's a vertical reflection. Therefore, there has to be an A that is negative. And guess what? That doesn't have A that's negative. That doesn't have A that's negative. Only this one does. This must be the answer. I just want to point out, when you have log of -x plus 1, yes, it's going to have a vertical asymptote, same place, x equals 1. But this -x is a horizontal reflection. Horizontal reflect. And that means it's going to be on this side. It's going to be on this side of the asymptote. It's going to move away from the asymptote in the opposite direction. Anyways, we knew that wasn't right because it was not vertically flipped. So we knew that wasn't right. But just in a future problem, you might see that. So we're settling on this one as being our answer.